Guys, this is the Unit 2 review for physical science. Hopefully you'll watch this video before you do your test at the end of Unit 2. So as you know, in Unit 2, it was all about matter and how we can describe and categorize matter to help us organize all of the information that exists within it. First thing you looked at was the structure of matter. So you learned about different types of atoms and how they can combine in different ways to produce different types of substances. So essential to understanding how substances form and being able to predict the type of substances that form is understanding the structure of an atom at an atomic level. What does an atom look like? What is it made of? How does it behave? All of those things. So in this unit, these were your objectives. Can you describe the structure of an atom and explain the ions and isotopes? Can you classify matter as a pure substance, a mixture, or a compound? Like, do you know the difference between those? Can you use the periodic table to predict properties? Okay, predict properties using the periodic table. Classify elements as metals, nonmetals, or metalloids based off of the periodic table. Look at an electron shell model and dot diagrams of atoms. Some of this might be review for you from middle school, so it's just good to look at it again. And then use the periodic table to predict the types and numbers of bonds atoms can form. That's based on the number of valence electrons they have. And then use standard chemistry nomenclature to translate between chemical names and chemical formulas. All right, so in looking at elements, different kind of atoms are called elements, and this little chart here reviews various elements on this periodic table. So if you click on one of these, you'll get information about, this is sodium. It's soft silver-colored metal. Pure sodium explodes in water. It's actually interesting to look at if you look up some videos of sodium exploding in water. It is one of two elements that makes up table salt. As you know, table salt is sodium chloride. Okay, and here's chloride. Chlorine is a greenish yellow gas. In its pure form, it's very poisonous. However, when you combine it with sodium, you get something that humans can ingest very safely. This is also the stuff you put into your swimming pool to keep it clean. Here's gold. Au is gold. Obviously, you know that its most common use is to make jewelry. It's a very heavy element, Neon is a gas. It's a colorless, odorless gas. It's very non-reactive. We call it inert. And it's used in these colorful lighted signs because it glows when electricity flows through it. And so on and so forth. I'm not going to go through all of them, but you can go ahead and click around and look at the different properties of the elements. Now, what you should keep in mind is that elements in this first row all have similar, column or group, all have similar properties. And elements in this last column all have similar properties. Helium, like neon, is also a gas. And it's also very non-reactive. It's also very inert. And that's because all of these elements in this group all have a complete valence shell of electrons, and so they are all non-reactive. So what you need to know is that the groups of the periodic table share similar characteristics and similar reactivities. Okay, so how do you combine the elements to make compounds? They can combine chemically to form compounds. Properties of compounds differ from those of the elements. We just talked about that when we talked about how sodium is super reactive in water and chlorine is a poisonous gas, but you put them together and you get something that's safe for us to consume. So they did 3 different materials here. Water is a molecule. It's made up of 2 hydrogens and 1 oxygen atom, right? Dihydrogen monoxide, di meaning 2, hydrogen, mono meaning 1, monoxide, that's water, H2O, okay? It's very non-reactive, but it is made up of 2 very reactive gases, hydrogen and oxygen, okay? Here's salt. Sodium and chlorine make table salt. The crystal is a piece of solid matter with a highly organized set of particles. So when salt forms, it forms in a crystalline structure. Again, just driving home the point that you can have 2 elements that have very, very, very different properties than the compound that they form. Here's the last one, marble. Marble is made up of 3 different elements, calcium, oxygen, and carbon. And they combine to form something called calcium carbonate, okay? So you'll notice that calcium is a gray, pretty dull metal. Oxygen is a colorless gas. And carbon is black. It's a black solid. But when you combine them chemically, you get this beautiful stone called marble or calcium carbonate, okay? So that's compounds. And then this video goes over the periodic table, how it's organized, with similar properties grouped together. I just talked about that. The columns and blocks of the table can be used to predict the properties of the elements in those groups. Okay, so watch this video to review how to use the periodic table.
Using the periodic table to make predictions. Sodium is a soft, shiny metal. Its atomic number is 11. And it is found in the leftmost column of the periodic table, along with the other alkali metals, which are also soft and shiny. Sodium is highly reactive. It reacts so violently with other substances that a small piece will burst into flames when placed in a dish of water. And most of the other alkali metals are even more chemically reactive than sodium. In fact, they are so reactive with other elements that none are found in nature as pure substances. Argon is a colorless, odorless gas whose atomic number is 19. It is found in the rightmost column.
The atomic number is actually 18. They misspoke there.
Column of the periodic table, along with the other noble gases. The name noble refers to the fact that these elements don't interact with the other ordinary elements. Radon is the only noble gas that might be found in a non-gaseous state in nature. The others boil at temperatures far below the coldest temperature ever recorded on Earth's surface. Argon is found in rocks and soil, and it makes up 1% of the atmosphere. It very rarely reacts with any other substances. In fact, it is so non-reactive that it is often used to fill light bulbs and to shield welding surfaces to prevent metal parts from reacting with oxygen and water vapor in the surrounding air. Considering how non-reactive the noble gases are, it shouldn't surprise you to see that they are found on the opposite side of the periodic table from the highly reactive alkali metals.
All right, so that's sort of an organization of the periodic table. They're organized by groups of similar characteristic elements. So this is the alkali metals, alkaline earth metals. And then if you jump across to number 13, this is called the boron group, the carbon group, the nitrogen group, the oxygen group, and then this in the column 17 is called the halogens. They're highly reactive, just like the first group, the alkali metals, and then the noble gases. Okay? Then you learned a little bit about valence and core electrons. So basically, valence, the word valence means outermost electron, whichever shell that might be in. Okay, so for example, in magnesium, the valence electron is in the 1, 2, 3rd shell. And in potassium, the valence electron is in the 4th shell. And in calcium, it's also in the 4th shell. But you'll notice that magnesium has 2 valence electrons, and potassium has 1 valence electron, and calcium has 2 valence electrons. If we go back to the periodic table, that magnesium and calcium had 2 valence electrons. They happen to be in group 2. That's not a coincidence, okay? The sodium you looked at has 1 valence electron, or I think it was potassium. 1 valence electron. It's in group 1. Again, not a coincidence. Okay, those are predictable patterns. Okay, covalent bonds. These are, instead of a complete transfer of electrons, you're sharing valence electrons to become more stable. Okay, they tend to form between non-metal elements, whereas ionic bonds form between one metal and one nonmetal. Let's watch this video.
Formation of a covalent bond. In an individual atom, one that is not bonded to any other atom, all of the electrons are centered around the nucleus of that atom in what we often describe as an electron cloud. The high-energy valence electrons extend farther from the nucleus than the core electrons. When an atom is covalently bonded to another atom, its valence electrons interact with the other atom. Here you can see 2 atoms approaching each other. They're going to form a covalent bond. Valence electrons of atom number 1 are attracted to atom number 2 and interact with it. At the same time, the valence electrons of atom number 2 interact with atom number 1. While valence electrons are forming a bond, the core electrons just stay with their own atoms. A way to describe a covalent bond is to say that the bonding electrons are shared between the 2 atoms.
An electron of this atom is attracted to this nucleus because the nucleus is positive. And the valence electrons of this atom, since they're closer to this nucleus, are attracted to this nucleus. Okay, and that's how they kind of stay together. Because of this attraction, they're sharing electrons. Okay, so that's covalent bonding. Ionic bonding, like I mentioned, is an electron transfer rather than an electron sharing. This is a bond that forms between atoms of very different electronegativities. So we're talking metals and nonmetals forming a bond. Let's watch the video.
Formation of an ionic bond. This chlorine atom has 17 electrons in 3 electron shells. The outermost shell contains 7 valence electrons. One chlorine atom can obtain a full octet by forming a covalent bond with another chlorine atom. To better show what's happening with the valence electrons, we'll condense the nucleus and core electrons of the atoms into a central sphere. When the single covalent bond is formed, 2 chlorine atoms have become a chlorine molecule. Chlorine atoms can also form a different kind of chemical bond with atoms of other elements. Here, a chlorine atom is about to interact with the sodium atom.
So if we look at what's about to happen, you'll notice that sodium has 1 valence electron here, and chlorine has 1, 2, 3, 4, 5, 6, 7. In order for chlorine to form an octet, it needs 1 more electron. And for sodium, if it can get rid of this electron, then it will have an outer octet in this second shell. Okay, so let's watch.
There, an electrical force pulled a valence electron from the sodium atom's outermost electron shell to the chlorine atom's outermost shell. Now neither atom is neutral. Both have become ions. With 1 fewer electron, the sodium ion is positive. With 1 extra electron, the chloride ion is negative. The opposite electrical charges of the 2 ions pull them together and hold them with an ionic bond. A chemical reaction has occurred, and the chemical compound sodium chloride, or table salt, has formed. Pairs of ionically bonded sodium and chloride ions stacked neatly together form the 3D structure of this cubical salt crystal.
Okay, so that's ionic bonding. And then you then looked at properties of matter, looking at physical versus chemical properties, explaining how the strength of force between the particles determine the observable properties of matter, and then explaining why the molecular level structure is important in the functioning of the material, analyzing, evaluating, and critiquing function of design materials, and then planning an investigation. So looking at chemical properties are those that give a substance a tendency to undergo a chemical reaction. So a good way to think about it is you can't observe a chemical property unless the substance has a chemical reaction, unless it is permanently changed into another substance. Okay, so these are 3 chemical properties that we can use to describe a substance. Reactivity is how quickly does it react to other substances. Rust, tarnish, those are all reactivity descriptions. The tendency to not form new substances is also a chemical property. Inert is how we would describe things like gold or neon gas. The second chemical property is flammability. How easily does it catch on fire? So gasoline, for example, is highly flammable. Wood is also flammable. But things like water is non-flammable. Materials that firefighters use to put out fires, they're obviously using non-flammable substances. A fire blanket is a non-flammable fabric, okay? And then acidity, how reactive is it with acid, or how acidic is it by measuring with a pH meter. Acidity is a chemical property that tells whether a substance behaves like an acid or a base. In food, acids taste sour, bases taste bitter. Many cleaning products are bases, including bleach and soap. Okay, so you can use a pH indicator to indicate the acidity or how basic a substance is. Physical properties of matter are those that you can observe without changing the substance. Okay, we can observe these without changing the substance. So here are some physical properties that are discussed here. One is basically the measure. How do you use measuring tools? Like, can you measure the mass? What is the volume? What is the density? Those are physical characteristics that you can measure. Physical characteristics of a substance you can measure without changing the substance itself. Okay, the temperature, that's another one. So those are physical properties. You can also describe what it looks like. How flexible is it? Can you see through it? What's the hardness? What's the texture? What's the shape? Those are all things that you can describe without chemically changing the substance. And then how it changes shape. Are you able to change its shape very readily? Is it malleable? And is it ductile? Ductile means it can be stretched and shaped into a wire. Like copper or gold, those are very ductile substances. You can roll them into a wire. Okay, malleable is just how bendy is it. So those are physical properties. Make sure you go back and review everything before you take your CST. And if you still have further questions, shoot me an email and we can set up a time to meet. All right, good luck.